and gentlemen, let's get this show on the road. Are there any comments or questions about anything so far?
You mentioned in previous lectures that there's a design template we need to follow when making methods. Do
Huh?
you need to indicate the return type if the return type is none?
No, you can just say none or leave it out. So the question is, in the design recipe, in the pattern that we follow when we define functions, if we have a return type, we type a little arrow and say what its type is. But what if we have a function where we don't return anything, we just have a side effect, we print or we draw something on the canvas or something like that? We can do it a couple of ways. We just leave the return type off, no return type, don't say there is. Or we can say returns none, and that does the same thing. So there we go. Thank you. Other comments or questions so far? Other things about anything at this moment? Okay, so the question is, what about the midterm, which is a week from today? And the question was, do I recommend studying from the practice midterms? I mean, there are a bunch of things you can study for in kind of priority order. I would say the previous quarter's midterms are the sort of best bang for your buck. And the quizzes and the lab assignments and the lecture notes we send out and the instructors, the books go in there somewhere. The instructor's comments on or answers on Piazza, recordings of the class, that's kind of in order. I might have forgotten one. I will send out a detailed email message probably this afternoon that lists those and other advice about next week's midterm. But yes, I think thing number one, that's going to get you the most effectiveness per hour spent is going to be looking at the past midterms, because this one will look more or less the same. Now, it's like they say with investments, past performance is no guarantee of future performance. I don't absolutely promise not to ask a question of some different kind, or the material is the material. Whatever we've been covering, but as far as I know, that's about the same as it has been in previous quarters. So that's that. Now, of course, when you use a sample test to study, the way to do that is not to look at the test, look at the question, say, yeah, I know how to do that. That kind of makes sense. Then look at the next question, say, yeah, I can do that one. Look at the next one, say, yeah, okay. And if the answers are available, look at the answer, say, yeah, that looks right, and keep on going. Instead, you should actually force yourself to take it as if it were a real test. If there are answers there, cover them up and sit down and take however much time you have and try to do all the problems. Right? And really try to do them with nothing but what's in your head. And then you actually see what you can do and you can't do, and you compare to the answers. And if they are not, if they don't match, then you have something to figure out. Okay, but don't just say, yeah, it looks okay, because not much happens in your brain when you do that. Okay, other comments or questions about that or anything else? Okay, great. And here is what we're going to do today, probably spilling over to Thursday. Maybe I'll teach you another little tiny piece of Python first. But then we're going to build a program from the ground up that actually kind of does something. So here's the new Python. Let's do that first. At the end of last time, we looked at loops. These are control structures. Right? A control structure is a way of combining statements into groups of statements or larger statements. So a function definition is a control structure, because control, when you say call the function, call double, you go to double, you do whatever, you return the value back. So the flow of control goes over there and comes back. Like use the chocolate icing recipe on page 23. You go to page 23, you make the icing, you come back to your main recipe where you called the icing recipe from, and then you continue the main recipe, which presumably uses the icing. Actually, while I'm thinking about that, there's one more little line to the analogy of cookbooks and icing recipes and cake recipes that we did last time. We had used a chocolate icing recipe on page 23 and a coffee flavored icing recipe on page 24 and an orange flavored icing recipe on page 25. And we had the chocolate cake recipe and the coffee flavored cake recipe and the vanilla flavored cake recipe and the banana flavored cake recipe. And when we have things nicely modular in that way, separate cake recipes, separate icing recipes, the chocolate cake recipe can call the chocolate icing recipe or the orange flavored icing recipe or whatever, and we can call the chocolate icing recipe from the chocolate cake recipe or the coffee flavored cake recipe or the banana recipe, right? And we have these interchangeable components. But there's one more step. If you think about the icing recipes, the chocolate icing recipe says, take a cup of melted chocolate and a cup of sugar and a cup of whipped cream and mix them all together. And the coffee flavored icing recipe says, take 2 cups of strong espresso and a cup of sugar and a cup of butter and mix them all together. And the orange flavored icing recipe says, take 3 tablespoons of grated orange rind and a cup of sugar and a cup of butter and mix them all together. And the, I don't know what else I have, the vanilla flavored icing recipe says, take a 1/4 teaspoon of vanilla plus a cup of sugar plus a cup of butter and mix them all together. Repetition, right? Duplicate code, right? Bad, bad, bad. We don't want duplicate code. What do we do? You all know the answer to this. What do we do to combine those 4 icing recipes so that we don't have the same duplicate code? We use starts with a P, 4 syllables. P-A, a parameter, right? We build a single parameterized icing recipe, a flavored icing recipe. And the flavored icing recipe says, take your flavoring, whatever that is, take your flavoring, plus a cup of sugar and a cup of butter and mix them all together, and there's your icing. And when we call the flavored icing recipe to get chocolate icing, we say, use the flavored icing recipe with a cup of melted chocolate. And when we want to use the flavored icing recipe to get coffee flavored icing, we say, use the flavored icing recipe with a cup of strong espresso. And when we say when we want orange flavored icing, we say use the flavored icing recipe with a tablespoon of freshly grated orange rind. Okay? The one part we change, we pass in as a parameter. The icing recipe takes that flavoring, whatever it is, does what it needs to do, and comes back. That's the parameter, right? So when we say define double n colon int, n is the name of the parameter. That's the flavoring. We don't know what it is, but that's what we call it inside the function, right? Say return 2 times n. When we have the flavored icing recipe, it says the flavoring. Take the flavoring and mix it with the sugar and mix it with the butter, and there's your icing. The parameter name in the flavored icing recipe is just the flavoring, and we substitute every time we call it whatever flavoring it is we're using. So that's the one sort of final issue with parameters and parameter passing. It lets us be more general, more flexible, eliminate more duplicate code. So let's see here. Okay, comments or questions about that, or about function calling? Okay, next thing. Control structures are the features of programming language that alter the flow of control. I guess we could call sequence a control structure. Print this out, read this in, print the next thing out, read the next thing in, assign list values, step, 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 step in a sequence. That's kind of the basic one. But we saw last time, and we're just talking about function calling, which is a flow of control. We go use the icing recipe and come back. But we talked last time about control structures for selection, if statements and their variations, where we choose one thing or another. Right? So if statements we use to select one or another, do something, skip some other things. And control structures for repetition, for repeating things. So we saw the for loop. We saw two kind of variants of it. Okay, so the for loop with range, I is a number. We use that if we need a number to index into an array, or if we just want to count things and print out line numbers or something. That's what we have. We also had the variant that just went through a sequence. This variable, the variable after the word for, is just a variable, but used in a for loop, we call it the control variable of the loop. In the first variation, it just takes numeric values, because range gives us a sequence from 0 to the argument -1, right? Range of 5, 0, 1, 2, 3, 4. If the item is a sequence itself, then the control variable gets the first thing in the sequence, then the second thing in the sequence, then the third thing in the sequence. So the same thing would be true with the string, right? Okay, So we saw that last time, but there it is again. Comments or questions about that? All right. So there's another form of loop, another control structure for repetition in Python and in most programming languages, and that's while. Basically, we use for when we're doing something a specific number of times. Not that you might cut out early or whatever, but for I in range 5, that's 5 repetitions, 0, 1, 2, 3, 4. For I in L, where L is a 6-element list, that's 6 repetitions, 1 for each element in the list. While is when we want to repeat indefinitely. As long as something's true. So the syntax of a while loop goes like this. We say while and some Boolean expression and a colon, and then on the body of the loop statements. And the semantics say evaluate the Boolean expression first off. If it's false, okay? So if it's false, we might do the loop, the body of the loop, 0 times. And so if it's false first time, we skip the body of the loop and go on to the next statement after the while. That's the one that's indented back out at the left margin again. If it's true, we do the body once, and then evaluate the Boolean expression again, and repeat. If it's false now, we're done. We go on to the next statement. If it's true, we do the body again, and then evaluate again. So you might do it forever. If you really do it forever, that's an error. It's called an infinite loop. But what you hope and expect is that if you do these statements, eventually they will change the value of the Boolean expression so that when you get to the end of the loop body and you go back and evaluate this the subsequent time, it won't be true anymore, and you'll skip through the loop and go on to the next statement. So we'll see some examples of that. But when your program calls for repeating something, you have to ask, what's driving the repetition? Is it some event in the program that I can test with a Boolean expression that's going to tell me when to quit? Or is it some sequence or some list where I'm counting items? And in that case, you'd use the for. In the previous case, you'd use the while. Okay? So we'll see examples of these as we go. But yes? Yes. So let me show you one more pattern. Let's see here. Okay. Sometimes, I mean, the way a while loop is built, you ask the question, you do the body of the loop, then you ask the question again. So there are some circumstances where you want to do part of the loop, and then you want to see, do I want to quit or not? And if you want to quit, you quit. And if you don't, you go through the rest of the loop and then go back and test again, or then go back and you want to do the first part again. The example we're going to see in a couple minutes that's one of the easiest is where you have an interactive program and you print out the menu, choose A, B, C, D, or E, and then you read what the person enters. And if E is for end, you quit. They type E for end. And if it's something else, you handle that somehow. And then you go back and you print the menu again. And then you check, did they type E for end? If so, quit. Otherwise, do the rest of the loop and then go back and then print the menu again. So you always, put it another way. With a while loop, normal form, you might want to do it 0 times. Okay? And it's built that way. If the first time you get to the while statement, the condition is false, Boolean expression is false, you just don't do it at all. And there are a lot of times when you want to do that. If you're processing something that could be full, could be empty, you don't know, that normal form is fine. But there are times when you want to do something every time, like print out the menu, right? You have an interactive program. The first thing you have to do is print out the menu. Even if the person wants to quit right away, if you don't say, here's the menu of choices, A, add, B, do something, C, copy, D, delete, E, end. If you don't tell them the menu, they're not going to know what to type, right? So you always have to print the menu, and then you want to check, is it time to bail? So the pattern we use for that goes like this. Okay, so while true, right, true is a Boolean expression, it's a constant, it's always true, so we better have some way to get out of this, otherwise we're going to be stuck in an infinite loop forever. But while true, so we go into the loop, we do that first group of statements, whatever they are, print out the menu, let's say. No matter what, then we ask the question, is it time to break? Did the user type end or quit or whatever? And break is a new statement that we're just learning, which says, go to the next statement after the loop. We're done with this loop, forget this loop, on to the statement after the loop. Right? Escape hatch, ejector seat. If the Boolean expression is not true, if the person didn't type end, we go on to do the second block of statements, which is presumably the body of the loop. In our example, it would be to take whatever they typed other than end and do whatever we're supposed to do when they type that command. Then we go back to the top, while true, all right, keep on going. Do the statements at the top, print the menu again, right? We did what you just wanted us to do. Now here's your choices again, redisplay the menu. And same thing goes over again. If the person types end, we break. Otherwise, we do the rest of the loop, go back, do the top part again, and check to see whether it's time to quit. Okay? Yes? Well, it evaluates the Boolean expression after the while, true or false. If it's true, you do the body of the loop. You do all those statements, and then it evaluates the Boolean expression again. It goes back and reevaluates. Well, it keeps on doing that until you're done with the loop. Either the Boolean expression evaluates to false, or you have a break statement, and then it goes on to the statement after the loop. Okay? Other comments or questions so far? Yeah. You can. The times you might want to use break in a for loop, suppose that you have a list of numbers, and you want to see if there are any numbers greater than 100, or 100 or greater. You can have a for loop that says for num in L, your list of numbers, and you can say, is num greater or equal to 100? And if it is, you found one, you don't really need to look through the rest of them, right? If the question is just, yes, I found it, then your answer is true, and you can break. So yes, you can. If you're going through a list and you have reason to stop looking before you hit the end of the list, a break statement is what would do that for you. Yeah. We'll see some examples of that, I'm sure, before we're done. Other comments or questions so far? Yeah.
How would break work in a nested loop?
Break jumps out of the innermost loop that it's in, right? So break just gets you out of one loop. It doesn't get you out of enclosing loops or enclosing if-elses or anything else. It just breaks you down to the bottom of that loop. You have another break statement there if you wanted, depending, but just one loop it gets you out of. Other comments or questions so far? Okay. So, armed with this, let's look at the program we're going to write. So don't look too hard at the code. We're going to build this code over the next day or two in class, and a copy of this code is available online. That you can download for the next lab assignment when you play with the code. Instead of going through this existing code line by line, we're going to build it up from the blank screen line by line, because that's more interesting, and that's what we'll do. What I want to do right now, though, since I have a version of the program written, is show you what it looks like when we run it. Okay, so here's what the program does, and then we'll start building it. So it says, welcome to the restaurants program. Gives us a menu, just the way we were talking about, with 5 commands, ARSPQ. And what we're doing is building up and maintaining a list of restaurants, so that we can look for a restaurant by name. We can add restaurants to the list. We can remove restaurants from the list. We can display our list of restaurants. And we can quit. So if I type Q for quit, thank you, goodbye, and we're done. Okay, if I do it again, and I say print all the restaurants, P, well, we haven't added any restaurants. We don't get anything. I can keep printing all I want. We haven't added any restaurants. I just get nothing, and I get my menu again. So let's add a restaurant. Okay, enter the restaurant's name, enter the kind of food served, enter the phone number, enter the name of the best dish, enter the price of that dish. Okay, that's the information we're storing about each restaurant. We've added that restaurant so we can print all the restaurants, and there's our one restaurant. You can add another one. So now I have 2 restaurants in my list. Let's add one more. Now I have 3 restaurants, right? And I print out each restaurant with a name and what cuisine, what kind of food they serve, phone number, name of the best dish, and the price of that dish. And there we have it. And here's my menu again. So what haven't we done? We haven't searched for a restaurant. Okay, if I ask for McDonald's, that's not in the list, so it gives me nothing. We could change our program to say, sorry, nothing there, but that's not how we did it. If I search for Taiwan, I get the information about Taiwan. If I had 2 restaurants with the same name, right, if I had 2 McDonald's, I'd get them both. So the one thing we haven't done yet, so here's my whole collection, 3 restaurants. I can remove a restaurant by name. Now if I print the collection, I just have 2 restaurants. That one called Thai Touch is gone. And that's it. We're done. Okay, so that's what the program does. There are variations we can include, which we will as time goes on, but for now, that's it. One of the first variations we'll want to make is to take our collection of restaurants and write them out to a file so we can read them in the next time we do the program, so that we don't lose everything we type, right? At the moment, we keep maintaining the list. When the program quits, everything goes away. That's fine for us to learn what we need to learn, but for a realistic program, you want to save that stuff. And to save things from one time you run the program to the next, you store them in a file. And we will learn how to write files and how to read things in from files in a couple weeks still. But that's something that this version of the program doesn't do, but the next version or the next couple versions will. All right, so are there any comments or questions about what this program does before we start looking at how to code it up? Yes? Well, we could write the program to do anything, but this program searches for the precise name because it's easier to code, right? So if you want, remember that, and as time permits, we can kind of add things to the program on the fly. But if this program doesn't look for a part of a name, it looks for the whole name, match exactly or nothing. You had a question? I'm sorry, a little louder? Oh, what if you type a command that's not a command? So X. Sorry, X isn't a valid command. Please try again. Good question. Thank you. There's another one over here somewhere a second ago. Yes, no, somewhere else. Other comments or questions about what the program does? Yes? The way it works now, you remove all the restaurants with that name. So the program just isn't written to distinguish different restaurants with the same name. You can have 3 McDonald's, and maybe they'll have different phone numbers. And maybe the best dish at one is a Big Mac, and the best dish at another is a Quarter Pounder or something. But the program is written. We will write the program to remove all the restaurants that match the name. If we wanted to do something else, we could, right? It's our program. We can change it to do whatever we want. We just took the simplest way first. Because, for us right now, 3rd week of the quarter, this will be complicated enough, right? It'll be like 3 pages of code. So, that's fine, but that's probably the biggest program we've seen so far. So we'll keep to the simple decisions to begin with. Yeah. Okay, you would write all the restaurants out to a file, and then when you run the program the next time, you read them back in from that file so you can add to that list. So we're not going to do that today, but we will do it in a couple of weeks. Yeah. Other comments or questions so far? As a principle, when you design a program, you don't try to code all the features you're ever going to want the first time through. Right? You try to write a simplified version that has the same structure, and then you add some pieces and add some pieces and add some pieces. And that's what we're going to do. right? And we might get through, probably won't get through the whole program today. We'll continue on Thursday. And when we're done with that first pass, with version 1.0 of the program, we'll have the program that does what we just saw here, still doesn't delete individual restaurants with the same name, still doesn't write the result out to a file to save them permanently, still doesn't do other things. Those are for version 2.0. Right? Because, you know, people's imaginations are pretty good, right? You can always think of something more or better that you want your program to do, and if you wait until your imagination is exhausted before you finally finish the program and start shipping it to customers, you're never going to be finished. And your competitor is going to be out there with a program that maybe doesn't do everything that was in your head, but they got something that people thought was useful, and they got it out there, and people started using it, and they got to the market first, which means they're probably going to be successful, and their company, their software is going to be bought by Microsoft or Amazon or Apple or somebody, and they're going to make a couple $100 million, and you're not. So, you know, developing incrementally and you know, is important for real life reasons. Okay, other comments or questions so far? Okay, so that's what we want. Whoops. Let's go back and start doing this program. Okay. One way of organizing programs like this, probably the best way for this kind of program, is to separate the user interface part, the part where we interact with the user, from what we could call the back end or the internals or the model. So that one part of the program prints out the menu, reads the user's response, prompts the user for the name and the cuisine and the phone and the dish and the price of each restaurant, prints out those restaurants in some way or another. That's all in one part of the program. And then the part that defines what a restaurant is, you can probably guess that it's going to be a named tuple with 5 fields, like name, cuisine, phone, dish, and price, and maintains the collection of restaurants, which is just going to be a list. It'll start out empty, and every time we add a restaurant, we'll add something to the list, and, you know, remove and go through the list and whatever. That's going to be separate. You know, lots of software design is about managing the complexity of the system. And even something like this is just 3 pages of code. It's complex enough that we organize it in certain ways. So we're going to organize it into the model part. Oops, other way around. Say it this way: the view, which is the user interface, versus the model, which is the way the program represents it. Why does that make sense? Well, it partly just makes sense to say, you know, here's this one set of functions, the input and the output and the displaying of things, and, you know, that's something we can put over on one side and think about it more or less independently from the rest. But it also makes sense because it makes things interchangeable, right? If you think about this program, right? This program interacts with a user in the console window, right? Well, that's okay for us, But if we're actually going to create something that, Apple is going to want to buy for $100 million, a console text-based user interface is probably not going to entice anybody, right? Nobody's going to download an app that interacts like this in the smartphone, right? It has to have a graphical user interface, right? It has to have, the elements that we're used to with buttons and keyboards and all that stuff. Well, the thing is, if we separate the view, the user interface part, from the model part, we can swap out the view that we have, the plain old text interface, and swap in an interface that works on a tablet or a smartphone or something without touching the model part. Because whether we're doing it on a smartphone or doing it in the Python console on our computer, maintaining the list is the same, right? Maintaining the collection of restaurants. We add a restaurant, we remove a restaurant, we search for a restaurant, we print out the restaurants, we display the restaurants. All those things are going to stay the same. And so we want to devise our program so that the things stay the same where we can, and if stuff needs to change, it's sort of isolated in one part where we can plug it out and plug it in. So this is called the model view pattern. Okay, so there's going to be the view part of the program, and there's going to be the model part of the program. And in the model part of the program, there's going to be a part that talks about restaurants, and a part that talks about the collection, let's say restaurant. All right, so there are two different things we're working with in this program. Individual restaurants, which we're going to build with a name tuple, name, cuisine, phone, dish, price. We'll see that when we get there. And the collection of restaurants, which is going to be a list, empty, bunch of restaurants, whatever. And those will be the two components of the model. And then there will be the view that will print the menu and handle the commands and deal with the errors and those sorts of things. So we could start either way. We could start with the model, or we could start with the view. The advantage of starting with the model is that it's typically the meatiest part of the program. It's kind of a bottom-up building block kind of thing. You build your restaurants and you build your collection, and then you use them in the view part. But if we start with the view part, we always have something we can run. And it might not do much, but at least we can see it run. And since this is an interactive program and we're not going to rely only on assert statements for testing things, it's nice if we can just keep running it and see that the next thing we added didn't break anything and we still get the same results that we expected. So we're going to start with the view part. And the first step will just be to write the main program. And the main program will take no parameters, right? It doesn't start with anything because it'll build up the restaurant. It starts with an empty collection. And it'll return nothing because it just prints and interacts, and when it's done, that's it. Now, we could make this into a function that returns a value and have it return to something else, the completed collection of restaurants, maybe to be written to a file or something. We could do it a different way, but this is probably the best way. Right? So this is going to be our main program. And because this is doing reading and printing and whatever, there aren't examples that we can give here for assert statements. So let's just write the body, and here's a synopsis of what we're supposed to say. Welcome to the restaurants program. And at the end, thank you and goodbye, right? So we can run this. And what happened? I have the definition of the program, but I never called it. So if I don't call it, I mean, there's the chocolate icing recipe. If I don't say use the chocolate icing recipe from some cake recipe, or you could make the icing recipe stand alone, but if I don't call the program, nothing's going to happen. So I need to call it, and I'm going to call it at the very bottom. No arguments. But I'll call it at the bottom because we want to have everything defined before we start executing. So now, if I run this, I have welcome to the restaurants program. I have thank you, goodbye. So I have the very first line, the very last line, but it works, right? No bugs, no problem. A very small subset of the original task, but I have something and it runs. And so as we continue to add things, we'll add things that keep the program running and keep the program producing perhaps not complete results, but correct results as far as we go. Okay, so call the program. Here's the main program so far. Comments or questions so far? Okay, so what else do we have to do? Somehow we need to build up a collection of restaurants. And so let's start out with a variable called our rests. That's going to be our collection of restaurants that we're building in the program. And we started out as an empty list of restaurants. And then let's have a function that does the main loop of the program, that prints the menu, takes the command, calls the appropriate command, changes the collection if necessary, and when it's done, returns the updated collection. So so handle commands let's see what we'll call this here. Okay, so handle commands takes a list. It's going to be a list of restaurants. And it's going to return a list of restaurants. Pass says, eventually we're going to put some code here, but for right now, just to fill out the body that doesn't do anything, we'll put pass. So pass is just going to return back again. But it's just a tool we use during development for writing what we call program stubs. Sometimes you want to write the skeleton of a function, and next you're going to fill in the body, but you can't do that all at once. So you say there's going to be a body here, but I don't know what it is yet, and pass does that. So we can run the program, and we called handle commands with this empty list. Handle commands didn't do anything but return back again, and we didn't do anything with what that return value was, and then we quit. So this function is going to print the menu, take the command, do the command repeatedly, adding or removing from the collection, and when it's done, the final collection is going to be returned back. That's the return value here, and we're going to assign it to our rests. So at that point, right? At that point, we could write that restaurant list out of the file. We're not going to do that today, this week, but eventually we will. So, so there we go. I think that's pretty much the structure for now of our main program. We print our greeting, we print our goodbye, we start out with an empty collection of restaurants, and then we pass the ball. At this point, the ball is an empty collection of restaurants to the next function, which is going to print the menu and deal with the commands and maintain the list. And eventually, at the end of this at the end of this function, we're going to return the restaurant collection as modified. Like so. Okay. So all right. Comments or questions about any of this so far? We have our structure here. Yeah, go ahead. Does let's say yes. I mean, it doesn't have to be. We could make it a totally global variable. But as a general rule, we're always better off defining variables, as far inside as necessary, because if we defined our rest out at the left-hand margin, we could do that, but it would mean that anywhere in the program could change our rests kind of wherever it wanted, which is a recipe for errors. So it's better to define it inside the main restaurants program, pass it to handle commands, which will return the modified value back, and we can keep track of where the ball is in the air from function to function. And if we just have a variable hanging out there, not part of any program, anybody on the field could grab the ball, to keep with the analogy, and that's anarchy. So that was a good question. Yeah.
For a list of restaurants, is that type of function? Type of R?
Is it a what kind of function?
Is it a type like list?
It doesn't return any type. It doesn't return a value. We just call it, and it does what it does. It runs the whole thing and creates the list, and maybe eventually we'll write it out to a file. But the restaurants program doesn't return anything, so it doesn't have a type, right? It just returns no type. That's why we say none. Is that your question?
No, I mean like the definition handle command.
Uh-huh.
Do we have the type list of restaurants?
Oh, okay. So the question is, how do we annotate more complex types using this annotation method, right? How do we say it? And there are a few alternatives. Because remember, this for our purposes, this is just for the human reader. So, probably the simplest way would just to be is to use the use the type name list that we have already in Python. That would be legal. It doesn't give us very much information. Another way would be to have a string where we say list of restaurant. That's probably, that gives us good information and is easy to type and easy to read. The downside of that is that if we ever were to write a program to try to parse this out and check it, it would be a little harder. We'd have to take the string and figure out, what it says inside, which is a little tricky. But this is also fine. Then a third way to do it, because eventually restaurant is going to be the name of a named tuple, which means it's going to be a type. We can indicate list of restaurant by saying bracket restaurant, like that. So any of those three would work. I think I'm going to use this form and forget about these other forms. Just because for us reading the program with where we are now, what we know now, that's going to be give us the most information. And we're not ever in this class. We're not going to write the code to actually check these annotations, maybe in ICS 33. So that's the form I'm going to do it, but those other two forms would be fine also.
So it isn't going to affect the function running?
Right. The annotations don't affect the running of the program, right? They're there for the human reader. Other comments or questions so far? Yes. So I did something instead of an empty list. I called some other function. Okay. So there are other ways to do it. We'll do it this way for now. We can look at the other way some other time. Yeah.
Is there a built-in function to check with the type of input?
There is the type function, right? So if you take some object and you say type parenthesis and the name of an object, it'll return you the type. I mean, it's in a little bit of a strange form. It says class, blah, 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 blah. But you can get that information from some object in your program, what type of thing it is. Well, you could do that. Yes, we're not going to learn it, but there is. Yeah, you have to kind of wait till ICS 33 or later, but yes. Good. Other comments or questions so far? You're right to want that, right? You're right to want an easier way. We're just, it's one of the things we're not going to get to. Yeah.
In other languages, do you have to define something before you call it?
Typically, although not always. So it's not a universal rule. It just depends on how the compiler works and whether the compiler goes through looking for things first and then goes back again, or whether it tries to do everything in one pass all the way through, in which case you want to have the definitions before you use them. Okay, other things so far. So we have our empty list we call handle commands, which takes the initially empty list and does things to it, like add more restaurants to it, and returns a modified list which we assign to our rests, and we're not going to do anything with it in this version of the program because at that point the user has done what the user wants to do, and we're done. We're not writing it to a file yet. So that's going to be it. The environment here, this environment, shows this grayed out because we assign it and we never use it. But for us at the moment, that's fine. We will learn eventually how to read things from a file and write things to a file to make this more permanent. Okay, so we have handle commands. We have these couple of alternative ways of expressing the types here for more complicated types. We'll just say list of restaurants because it's the clearest for reading. And so handle commands needs to print the menu and do some other things. So let's just see what that's going to look like. I think the first thing we need to do is say what our menu is going to say. So that can be a constant in our program because we're never going to change the menu. Okay, so we have a long, 6-line string here. That's a constant in our program. So constants we can define out at the outside level. We're not going to change them. We follow the convention of naming constants with all caps, the way we did with tax rate a couple weeks ago. That's not required by Python, but it's required by the community of Python programmers. It's a convention that we follow. And so now let's look at our program here, and this is a job for our n½ times loop pattern. Okay, so we call the input function with an argument, namely our menu string. So it's going to print out the string, wait for the user to type something, take what the user types and return it, and assign it to command. And then we'll say if the command is Q for quit, break, we're done. Otherwise, right, and this is another kind of a stub. We're just going to print, you entered this command, and that's it. Right? Then we return the restaurant, which we never changed. Right? The restaurant comes in at this moment, right? Preliminary version. We're just checking the control. And after we're done with the loop, right, when we finally get a Q, we'll break, then we'll return the same unchanged restaurant collection that we started with, and we don't need this anymore. So we're set. So if we run this, we have our welcome line, we have our menu. If I say Q, thank you, goodbye, we're done. If we run it again and say X, you entered the command X. A, B, W, P. Hello. Okay, I mean, I can type whatever I want, and the program just reads it in. We'll deal with the error message in due course. But when I type Q, we quit. All right? So, comments or questions about, yes? Yes. Probably the easiest way to do it would be to say if command equals Q or command equals Q, that would be probably the easiest way or the most clearest way with what we know. We could also say if the command, here'd be another way to do it, a little less typing. Right, so I make a list with the various versions of the command I'll accept, and I'll say, is the command in this list? And that's going to come back yes or no, actually. Give you both of those versions. So that would be another way to do it. Another way to do it would be to I can call the lower method. I mean, you guys don't know this yet, but you'll learn it eventually. There's a method on strings that takes the string and changes all the letters that are uppercase to lowercase. So I could just say whatever you type in, uppercase, lowercase, make it lowercase, and then just check the lowercase letters. So there's a variety of ways of dealing with that issue. I mean, from a design standpoint, I guess I would say that unless somebody has their caps key locked, right, they have caps lock on, unless they have that, the likelihood that they're going to type a capital letter when we show them lowercase letters is relatively low. And if we have the error message that we're eventually going to have, you type capital Q, that's not a valid command, they can probably look and see that there's a difference. So, I mean, it's generally better to make things case sensitive, but it might not be as crucial here as it is in some circumstances. Good. Other comments or questions so far? Yeah.
How come the function and the command has access to the variable menu?
Because menu is defined out at the left margin, not part of any function, which is okay because it's a constant. We're never going to change it. So if we're never going to change it, we don't have to worry about somebody from off on the sidelines of the field grabbing our ball and messing with it. It's just there, stays the same through the whole program. So we can leave it at the global level. Yeah. Okay.
Would it be possible to use the lower on where you said command is equal to the input? Would you be able to input dot lower?
Well, I'd actually have to, because lower takes an object, I'd have to take this and then say command gets command dot lower that way. But that's where I would do it, yes. Other comments or questions so far? Okay. So let's see what else we can do. This is, okay, I did this. I ran this, so we know that we have the quit command. We have the quit command. I'm going to leave it all just lowercase here. Okay, So we have the quick command. We know that that works. Let's just run it again. Whoops, not here. Okay. I fiddled with the code. Probably a good idea to rerun it to make sure I didn't fiddle with it in a way that breaks it, which I just did. Just did fiddle, not just did break, not this time. Okay, so let's do a fuller version of the handle commands function. So I can redefine it. I don't even have to call it handle commands 2 necessarily. And it's going to do the same things. I'll take out these variations. And now instead of just handling the Q command, let's handle all the other possible commands. Again, in stubs. So the A command, and let's just, again, let's just have a stub here. Right, what we're going to do is add a restaurant. Eventually there's going to be a function call that adds the restaurant. Well, it's not going to have to actually get the information about the restaurant, create a restaurant object, and stick that restaurant object onto the list of restaurants. We have to do all those things. So I'm going to just say, here's what we're going to do. And right, and this is a stub. It doesn't do anything except print out what's going to happen, but that'll advance the cause. So we have A and we have R. Here's where we print the error message, right? So if the command is Q, A, R, S, or P, we have something to do. Q quits us out of here. In this case, A, R, S, and P just print what we're going to do. Eventually, they'll actually do those things. But if we don't have any of the commands, then we need to say, okay, and that should do it, and we don't need this anymore, and we're set. So, well, let's leave it for now. All right, so instead of just one if, we have if, elif, elif, elif. We sometimes call this, did I say this last time, an if ladder, right? It kind of looks like a ladder here. There are a bunch of rungs on the ladder, and we go and find the one that matches, and we do what we're going to do. If we don't find a match, we print out a nice error message. It's good that the error message says what we think they typed. And then that's the bottom of the loop. So we go back again and print the menu out again. So, all right, so this should work. And A, add a restaurant, A, add another restaurant, R, P, S, P, X. Sorry, X isn't a valid command. Please try again. Hello. Isn't a valid command. Please try again. And quits. The only thing we might quibble with here is the extra spaces around the command, because actually if they typed space something, that wouldn't match what we're checking for, so it would look a little weird. There is a way to deal with that, and I'll just tell you what it is. Normally, each item in the print function is separated from the next when we print with a space, right? We've seen that. We print one thing, another thing, another thing, and the print command adds one space in between each of the items. We can make that separator something else, including the empty string. And now so if I type space Q, it'll say, sorry, quotes right around space Q, so at least it tells me, if I'm astute enough to see that there's a space there, it gives me a clue of finding out what the problem is. Please excuse me. All right. So, comments or questions about this one? Yes? No? Well, I have a minute. Question about anything about this code so far? Okay, then. We'll resume this on Thursday. Thank you very much. I'll see you then.